Hey everyone, ready for another deep dive. You know all those incredible James Webb Space Telescope images we've been seeing? Well, today we're going way beyond those icy giants.
Oh yeah, even farther out than Pluto.
We're talking about those mysterious objects lurking in the outer reaches of our solar system.
That's right, we're heading beyond Neptune into the realm of trans-Neptunian objects, or TNOs for short,
TNOs?
like time capsules from the very beginning of our solar system.
Okay, time capsules. I like the sound of that. But
hmm
before we get too far ahead of ourselves, can we back up for a sec?
Sure.
What exactly are TNOs?
Well, imagine
Yeah.
our early solar system.
Okay.
It was like this massive construction site with dust and gas swirling around,
Yeah.
eventually forming the planets.
Right.
TNOs are like the leftover bits and pieces scattered out in the solar system's suburbs.
Like cosmic leftovers.
Exactly. And because they're so far out, they've been basically frozen in time for billions of years.
Makes sense.
Hmm.
But you said they're important.
Oh, they are.
What makes them so special?
Think of it this way. They contain clues about the early solar system that we can't find anywhere else. By studying their composition,
Okay.
we can actually piece together a map of the original ingredients present when planets were forming, like a cosmic recipe book.
Whoa, a cosmic recipe book? That's pretty awesome.
It is.
And this is where the James Webb Telescope comes in, right?
You got it.
It's powerful enough to see what these TNOs are made of.
Exactly. Before Webb, we could only guess at their composition. But now, thanks to its super-sensitive instrument called NARSPEC, we can actually see the specific molecules on their surfaces.
Okay, break this NARSPEC thing down for me. How does it work?
Imagine shining a flashlight on a TNO.
Okay.
NARSPEC acts like a prism separating the reflected light into a rainbow of colors.
Right.
And just like every element has a unique fingerprint, each color tells us about a specific molecule on the TNO's surface.
So NARSPEC's basically giving these TNOs a full-body scan revealing their chemical secrets.
Precisely.
That's incredible. What's it uncovered so far?
Get this. Webb has discovered 3 distinct spectral classes of TNOs, meaning they have different surface compositions.
Like finding different flavors of ice cream out in the Kuiper Belt.
Aha, yeah, something like that. We call them bowl type, double dip, and cliff.
Okay, 3 flavors, huh? I'm hooked. Tell me more.
All right, so bowl types, they're named after their spectral shape.
Makes sense.
They seem to have lots of water ice,
Hmm.
a bit of carbon dioxide ice, and a hint of dust.
Interesting.
Probably formed closer to the sun where things were hotter and some of the more volatile compounds evaporated away.
Gotcha. So they're like the well-done ice cream. Everything's kind of blended together. What about the double dips?
Now, those are interesting. Double dips have a more complex mix.
Hmm.
We're seeing complex organic molecules, carbon dioxide, and carbon monoxide ices.
Wow.
And here's the kicker. They have these unique reflectance peaks in their spectra, something we've never seen before outside a lab.
Wait, really? We're seeing something brand new? What do those double dip peaks tell us about these TNOs?
Absolutely. It's like they have a secret ingredient that we're just now beginning to understand. And then we have the cliffs.
Okay.
These guys are even more intriguing.
More intriguing. I'm all ears.
They have even more complex organics than the double dips,
Okay.
plus carbon dioxide and methanol.
Wow.
And here's the really fascinating part.
Okay.
All the TNOs we've found in what we call cold classical orbits, think of them as the most pristine, undisturbed objects in the Kuiper Belt.
Gotcha.
They all fall into this cliff category.
So you're saying the objects farthest out, the ones that should be the most basic, have the most complex chemistry. Why is that?
That's a great question, and it gets to the heart of what makes these TNOs so fascinating. You see, they're not just icy rocks floating in space.
Right.
They're pieces of a puzzle that can help us understand the very origins of our solar system.
Okay, I'm definitely intrigued. Tell me more about how these different flavors help us understand the early solar system.
Well, remember that cosmic recipe book I mentioned? By analyzing the different compositions of these TNOs,
Yeah.
we can start to map out the original ingredients that were present in different parts of the protoplanetary disk.
Wait, protoplanetary disk, you lost me.
Ah, right. Sorry, astronomy jargon. Think of the protoplanetary disk as a giant swirling cloud of gas and dust that surrounded our young sun billions of years ago.
Okay.
It's the raw material from which the planets were born.
So these TNOs are basically frozen samples of that original cloud.
Precisely. And the fact that we're seeing such distinct spectral classes suggests that this cloud wasn't uniform.
Okay.
It had different regions with different chemical makeups,
Right.
and those differences are reflected in the TNOs we see today.
You know what? That's mind-blowing. We're actually looking at the building blocks of planets frozen in time.
Exactly. And that's just the beginning of what Webb is revealing.
Oh, wow.
There are TNOs with their own moons.
Really?
TNOs that travel so far out, they almost reach interstellar space.
Wow.
And even TNOs that orbit each other in pairs.
Whoa, whoa, whoa. Slow down. So much awesome at once. I need to know more. Okay, you mentioned TNOs with their own moons. Talk about a family affair. What can we learn from these little mini solar systems?
It's amazing, right? These binary TNO systems can help us understand how TNOs formed in the first place.
Okay.
Were they born together from the same clump of material in the protoplanetary disk, or did they collide later on and get gravitationally stuck? Webb will be able to analyze both the TNO and its moon,
Oh, wow.
giving us clues to their shared history.
So it's like a cosmic game of capture the flag, but with gravity instead of flags.
Haha, what's that?
And what about those extreme TNOs you mentioned, the ones venturing out towards interstellar space?
Ah, yes, those are like the ultimate time travelers.
Hmm.
Because they orbit so far from the sun,
Yeah.
they've experienced very little gravitational interaction with the rest of the solar system. They're like pristine relics of the early solar system, frozen in a deep freeze for billions of years.
Now that's what I call social distancing. Imagine the secrets they hold just waiting to be unlocked. I bet studying those is like getting a glimpse into a completely alien world right here in our own solar system.
Precisely. And speaking of revisiting Webb, we'll also be taking a second look at some of the TNOs it observed in its first year of operation.
Oh, cool.
This time it will be gathering even more detailed data,
Okay.
building on what we've already learned and refining our understanding of these icy worlds.
So it's like going back to a favorite book and discovering new details you missed the first time around. With each observation, we're adding more layers to this incredible story of our solar system's origins.
That's a great analogy, and it's not just about our solar system either.
What do you mean?
By studying these TNOs, we're also gaining insights into the formation of planetary systems around other stars.
Oh, wow.
After all, if TNOs represent the leftover building blocks of planets in our solar system,
Right.
then it stands to reason that other stars might have their own collections of TNOs too.
So we're essentially looking for cosmic cousins out there in the vastness of space.
In a way, yes. And by comparing our TNOs to those in other star systems,
Okay.
we can start to understand how planetary systems form and evolve across the universe.
This is making my head spin. We're going from understanding the early solar system to contemplating the diversity of planetary systems across the galaxy, all thanks to these little icy objects.
It's a testament to the power of scientific inquiry, isn't it? And we're only just scratching the surface.
Wow.
Think about it. If our solar system is anything to go by, the universe must be teeming with planets.
And some of those planets might even harbor life. It's an incredible thought.
It is.
But let's not get ahead of ourselves. We've covered a lot of ground today. Maybe a quick recap would help ground us before we launch into further speculation.
Good idea. So to summarize, trans-Neptunian objects are icy remnants from the early solar system lurking in the darkness beyond Neptune.
Right.
They act like time capsules, holding clues about the formation and evolution of our planetary neighborhood.
And thanks to the James Webb Space Telescope, we're finally able to analyze their compositions in detail,
Exactly.
revealing a surprising diversity of spectral classes, each with its own unique story to tell.
These spectral classes suggest that the protoplanetary disk, the swirling cloud of gas and dust from which our solar system formed, was more diverse than we previously thought, with different regions having different chemical makeups.
And by studying TNOs both individually and in binary systems, we're not only piecing together the history of our own solar system, but also gaining insights into the formation of planetary systems around other stars,
Yeah.
potentially opening a window into the existence of other worlds and even life beyond our own planet.
It's truly an exciting time to be studying these distant icy objects. Who knows what other secrets they hold waiting to be uncovered by future observations. Perhaps they hold the key to understanding not only our own origins, but also the potential for life elsewhere in the universe.
Okay, you've officially blown my mind. But before we spiral too far down that rabbit hole, I think it's time to start wrapping things up. We've taken a deep dive into the fascinating world of TNOs, explored their diverse compositions, and considered their implications for understanding both our solar system and the wider universe. But before we go, I want to leave you with something to really think about.
Okay.
We talked about how TNOs are like time capsules, holding on to secrets from the early solar system.
Right. And we've seen how their compositions vary depending on, their distance from the sun.
Yeah.
It's like a cosmic gradient with different ingredients available depending on how far out you were, in the original protoplanetary disk.
Exactly. So here's the big question.
Okay.
If these TNOs represent the building blocks of planets, what might they tell us about other planetary systems out there in the vastness of space?
It's a mind-boggling thought, isn't it? Imagine countless star systems, each with its own collection of TNOs, icy remnants of planetary formation.
Right.
Are some of those systems similar to ours, with the same diverse mix of TNOs?
And if they are, what might those TNOs tell us about the planets that formed alongside them? Could they hold clues to other Earth-like worlds, or Maybe even planets that could support life.
It's a question that will keep astronomers busy for generations to come.
Yeah.
But thanks to the James Webb Space Telescope, we finally have the tool to start searching for answers.
It's like we've been handed a cosmic treasure map, and now we're setting out to explore uncharted territory, you know? This is just the beginning of an incredible journey of discovery.
And who knows what other mysteries await us out there, in the darkness beyond Neptune. With each new observation, we're peeling back another layer of the cosmic onion, revealing more questions than answers.
Yeah, it's enough to make your head spin.
It is.
But isn't that the beauty of science? The more we learn, the more we realize how much more there is to discover.
Exactly. So keep looking up, keep asking questions, and never stop exploring the wonders of the universe.
Yeah.
Because as we've seen today, even the most distant icy objects can hold the keys to unlocking some of the biggest secrets of the cosmos.
That's it for our deep dive into the secrets beyond Neptune. We've journeyed to the outer reaches of our solar system, explored the diverse compositions of TNOs, and pondered their implications for understanding the universe at large.
We've learned that even the smallest, most distant objects can hold profound clues about our cosmic origins.
So keep those questions coming, and we'll do our best to keep exploring and sharing the wonders of the universe with you.
Until then, keep looking up and keep wondering. The universe is full of surprises, and we're only just getting started.